Good, mawaya naman dyan. Okay, so that will be your range. Nga na lang pagkuha sa range. Simply subtract the lowest
Okay,
value
so
from
good
the
afternoon,
highest.
everyone. It's already
Now we also
5:40,
have
so I
the
think
second
we
natural
can start
situation,
with our
that is the
discussion.
standard
So for our
deviation.
module
That is
6
the
again,
first one that I
this
have
is
introduced
all
to you
about
in your class,
mathematics of
that we will be
graphs.
talking about
And
differentiation.
before we will start, I would just
Yes.
like to ask if okay ra ba nga ako boses? Am I
Okay.
audible?
Thank you. Okay. So we'll go to
Okay.
the standard
So again,
deviation. This is
last
the other
meeting, of
measure
course, we
of
discussed
precision.
about
Now, when we say standard
the
deviation, it is the
basic
square
concepts
root
of
of
graph theory,
the
and we
variance.
also
The
discussed
standard
about the
deviation of a
Euler,
set of
right? The Euler
piramidal
circuit, the Euler
given
path,
the minimal
right?
amount that each
So
data
this
value
time,
deviates from the mean.
we'll
And
go
that's the
on to our
reason why the
lesson 2
given
again.
equation.
Nana lang
Okay,
tayo
bali,
duha ka
ang
topics na
standard
nabilin.
deviation, it
And
will
so
tell you
after this
sloping
one,
down
we'll just
interval
have to
valid data
tackle
point,
one last
and then
topic.
it will also tell
No,
you kung
and
sila
it's
ang
just so
distansya
nice kay
ng
grabe
atong
na nato
data point
ka-advance,
from the
gipaspasan nga
mean.
gani.
So the
But
closer the
anyways,
standard deviation
we are
to
now on
zero,
our
the
second to
lower
the
the
last topic,
data
and this is all about
variability,
the
and the
mathematics
more
of graphs. And
reliable the
part
data
of
is.
that is also
The
about
standard deviation
lesson 2,
equal to
and
zero
lesson 2
indicates
is
that
all
every
about
value in the
again
data set
the
is
Hamiltonian
equal
paths and
to
circuits.
the
Now,
mean.
you will just have to
So of
define the
course, from
difference
zero imo
between
ang
the
mean, let's say
circuit
for
or,
example, it's
or
100.
Euler circuit and the Hamiltonian circuit
Kung zero ang
and
imuhang mean
Euler
o
path
nag-zero
to
po ang
Euler
imuhang
circuit.
standard deviation,
So again,
you
this
will
time
be
we have
adding
here
literally zero to all the data
mga
points and then it is
lessons.
equal to zero.
Now that in this
By
lesson, you
then,
will be able
you
to,
can
of
also
course, determine
conclude
whether the
that
graph
all
is
of the data
Hamiltonian
set
or
are
not.
equal to
You could
the
also be
mean.
able to
So the
demonstrate a
higher the
Hamiltonian
standard
graph through
deviation,
different
the more
examples.
variation there is in
Apply
the
Dirac's
data,
theorem to
and the less
verify that the
accurate
graph
the
is
measurement is.
Hamiltonian.
Now, this
And
equation
apply the
for the
concepts
standard
of
deviation is
Hamiltonian
given
graph
by
to
the
real-life
following.
scenarios. So
Na
we
type
have
sigma.
here
So sigma can
our
be.
pre-assessment. So again, maybe dili na siguro nato need
Okay,
na
that's
answeran.
sigma.
But anyways,
Again,
let's just go
pagbataan
to our
niya, that
lesson
is
map. No?
sigma.
And we have here
Okay,
Hamiltonian graph.
sigma.
So,
Sigma
when
denotes the
can we
standard
say that that is
deviation
a
of a
Hamiltonian graph?
population,
So,
and
naiduha ka
whereas
parts
this
Hamiltonian graph. We
denotes the
have
standard
the
deviation
Hamiltonian
of
path
a
and the
sample.
Hamiltonian
Now, ma'am, how do
circuit.
we calculate the standard
So,
deviation?
in here,
We have the
again, this
procedure
is
for
just the same with
computing
our first
the
lesson,
standard
no,
deviation
about
using
the
this
conics
written
verge,
method. So first,
right?
determine
So,
the mean
of
of
course,
the n or
some of
n
you
first.
have
Being small
answered
letter
about
n,
those
that
things.
denotes the
But,
sample,
sa
and then big
katuna, kuha
letter
nato
N,
is
that
naghisgot
denotes the
ta about
population.
mga
So depende
edges,
kung ano
right?
yung pangatsuhan.
About
For
edges pa
example,
siya. So, it
sample
talks
lang, sa
about
annotation
the
ninyo na
path
gamiton will
na imong
be
mga agianan.
S.
Okay, wa pa
But
siya
if it
naghisgot ng
covers all the
vertex. In
population or the
here,
entire
no,
population, we will
is
be
that
using
you
the
will visit the city
sigma.
of Königsberg.
Now, after you
Notice that
determine
the
the
city has
mean
7
of the
bridges. In
sample or
order
the
for you to save money and
population,
time,
you
you
proceed to the
decide to
step
find a route that will
for
cross
each
all the
number,
bridges exactly once
calculate
in
the
visiting all parts
deviation. By
islands of the
that,
city.
we
So this time,
difference
before,
between the number and the
we
mean
talk
of
about
the
the
numbers.
agianan.
Step number
Okay,
2,
this time,
calculate the
what we
square root
will
of each
gonna
of the
do with this
divisions and find
engaged
the
part
sum of
is
each
that
square root
dapat
of the
maagian
divisions.
nato tanan
Step
na mga
number 4,
vertex.
if the
Okay,
data
tanan na
is
mga vertex.
population,
Before, our last
then we
topic was
provide the sum
dapat maagian
of
nato
n.
tanan
If the
agianan.
data is a sample,
Karon,
then
dapat
divide the sum
maagian
by
nato
n
tanan
minus 1. Do
syudad
not worry because
nga
we do have
naa.
a concrete
Okay?
example today.
So again,
Ato lang
dapat
sa
magian
base,
nato ang
standard
tanan ng
deviation
mga
is
edges before sa ato lesson 1. This time, dapat
now,
magian
step
nato
number
tanan
5, find
vertex.
their
Di ba ang vertex nato
population.
diri kay
Step
mga
number
lugar?
4, and we have
Okay.
here a note
So,
that the sum of the
in here,
divisions is
after that,
always 0.
of course, you will
So
have
for
to
you
answer
to
process
check if saktang
questions.
imong
I'll just put
calculations, you
this
have the
again
sum
on
of the
our
divisions or the sum of the difference, and it will
flare as
always
your
equal to.
assignment. We also have here travel
Okay, you can use
goals.
this fact to
Isay
check
mga
the
laagan
accuracy
diha
of your
na
calculation.
bisag klase na
Now,
asa
aside
na,
from
na
the
birthday,
range,
bisag
the
klase
standard
na ay
deviation, we
nag-jogging,
also have the
bisag klase
variance.
na ay
The
nangaligod
variance
dagat,
for the
bisag klase
given
na ay
data set
nag-iinom.
is the square of
Halatang
the standard
laagan. No,
deviation
labo
of
man ang way
n.
klase kay
So if
magpudyo
you
ka ng subay,
already
labong
have
ti
the
klase
value
kay
for your
maglaglaan.
standard deviation, it will be
So
easier for
anyways,
you to do
of
your
course, I think all
variance.
of us,
Now, we
or
have the
maybe some of
condition for
us,
the
has this
variance.
travel goals,
We
no?
have first
And this will
that
actually
is
help us
sigma
in traveling. No? So
sigma
below
squared
here is the
the
map of
variance of
all
a
beaches
population and have S squared.
Beach.
That is the variance of
No,
S
in
sample.
letters
Now we have
in
a
Surigao
formula
City.
here.
So,
S
if
squared,
you are a
the variance of
biker
the
and
sample,
would like to
is just
traverse or
equal to the
traverse or
summation
pass
of
all
the
the beaches
square of
exactly
quantity
once.
xi
So,
minus
dapat daw
the mean
maagian
all
nimo
over n
tanan na mga
plus
beach sa
1.
Surigao
So S squared is
kaisara.
what denotes the sample
Okay?
variance.
Okay?
And
Again,
xi,
nagian nimo
that
tanan
denotes
na
the
mga
value
beach
of
sa
the
Surigao kaisara.
population.
Wala nagmatter na
Or
dapat
S
agian
bar,
nimo
that is
tanan
the mean
agianan
of all the
as long as
observations,
dapat agian nimo
and
ang
that is
tanan
the
na
number
mga
of
um,
observations.
beach
Okay, so let's
sa
try an
Surigao
example.
City. So
A
after that,
valid
we also
number
have
is
here possible
obtained
questions.
by
Now
a
let's talk
sampling
about
population.
Hamiltonian
The data
paths and
point
circuits.
given data
So
sets
again,
are
let's just
1,
define
2,
first what is
5,
Hamiltonian
7,
paths,
8.
and let's also
Solve
define
for
what
the
is a
range. To
Hamiltonian
solve the range,
circuit. So
we
in here,
identify
we
the
have here
highest
a
value, that
Hamiltonian
is A. The
circuits,
lowest
no?
value is
So we have here
1.
our
So
definition,
highest value
no, a
minus
path
the
on a
lowest
graph
value,
that goes
that
through
will be
each
your range.
vertex
That we
once
have
is
8
called
minus
Hamiltonian
1,
path.
which is 7.
So
Therefore,
again,
the range
a
is
path daw
7.
sa graph
Now,
na
solve the
moagi
standard
sa tanang
deviation.
vertex
So, ang first
kaisa,
step to
ang
solve
tawag
standard
ana is
deviation,
Hamiltonian path.
determine the mean
Okay?
first, or the
Agian mo
average.
tanan
So we have
vertex
add
kaisa,
all the data
tawag is
points in your
Hamiltonian
data
path.
set and
A
divide
path
it by
that
the
starts
number
and
of
stops at
data
the same
points.
vertex
So
and
here,
goes through each
ang ating
vertex
data points
once
are 1, 2,
is
5,
called a
7, 8.
Hamiltonian
So we write down
circuit.
1 plus 2
Again, a
plus
path
5 plus 7
that
plus
starts
8
and stops at the
divided
same
by 5.
vertex
5
and goes through
because
each
we
vertex
have
once is called
5
a
data
Hamiltonian
points
circuit.
in
So,
our data.
sa Hamiltonian
1,
circuit,
2,
if you started with letter A
whenever you
and
see
then
this
kinahanglan
symbol,
agian nimo tanan na mga vertex,
that's the main
tas
one.
mo balik
Okay,
ka
so we have
sa
here 1
vertex.
plus 2
Okay,
plus
mag-end
5
ka sa
plus
vertex.
7 plus
For
8,
example,
that is just
if you
equal
start
to
at A,
23
tapos gagyan mo tanan ng mga vertex and
and
then
that
you
is
end
just
at
equal to
vertex A ra
4.6.
gihapon, that is what you call
Now, after
Hamiltonian
you look
circuit.
or after you solve
Okay,
for the
kinahanglan
mean,
kaisa ra
what
nimo
you
or
proceed to
nagian
step
nimo
number 2.
tanan
So
vertex
step number
kaisa.
2, for each data
And
values,
ibalik ka sa katong
calculate the
vertex na
deviation
imong
between the
gisundan.
data
That is
values
what we
and
call
the
a
mean.
Hamiltonian
Again,
circuit.
deviation that will be
So a
the
graph that
difference.
contains
So
a
given our
Hamiltonian
data,
circuit
the
is
variable
called
x,
Hamiltonian
that's
graph.
1, 2, 5,
Again,
7, and
matawag
8,
siya na
we will
Hamiltonian graph
calculate
if
the division.
it is a Hamiltonian circuit. Now again, what is a Hamiltonian circuit? If naakay agian nimo tanan vertex and ang end sa imo graph is still on the vertex nga di sa kaw nag-start. So we have here an example na ni mga Baguio, Manila, Quezon City, Puerto Princesa, Iloilo City, Zamboanga, Cagayan de Oro. In that, no, matawag natin siya na Hamiltonian path because
that for you to check if your calculation is correct, simply add
okay, matawag natin siya na Hamiltonian path. Ganong Hamiltonian path raman si Jama. Because, no, like for example, nag-start ta sa Baguio. And then, ning-agi ta sa Bacolod, Cebu, Cagayan, Davao, Zamboanga, Puerto Princesa, Iloilo City, and then Manila. Nagian ba nato tanan vertex?
Makita ninyo? What about this one? Makita?
Nagian ba nato tanan vertex?
Okay. So,
Everyone?
atong i-check, atong i-zoom na lang ang kwanza. Okay na? Klaro na? Okay.
Hello, naagian ba nato tanan vertex sa kana na graph?
Nag-request.
Yes. Naagian nato ang tanan vertex sa kini na graph.
So,
Unsa pa galing tong vertex? Katong
correct under the deviation,
mga lugar or katong toldok inang vertex sa ang edges or edge mo na ang mga lines nga nag-connect sa mga vertex. As you can see here, nagyan na to tanan vertex, bahala dili na to magian tanan mga linya or mga edge. Basta kay nagyan na to tanan vertex. No, and matawag siya na Hamiltonian path because nag-start siya sa Baguio pero nag-end siya sa Manila. Okay, Hamiltonian path siya kay waya siya ni balik sa ija end. Pero if Manila ka tas gibutang nimo sa end nimo is Baguio, matawag ta na Hamiltonian circuit. Like for example, this one. Nag-start ka sa Baguio, then Quezon City, tapos ang Bacolod, Cebu, Cagayan, Davao, Zamboanga, Puerto Princesa, Iloilo City, Manila, and then you go back to Baguio. That is what we call a Hamiltonian circuit. And if that is a Hamiltonian circuit, then we can call that one as a Hamiltonian graph.
Always, and this is a fact, no?
Is it clear,
Again,
everyone?
it is a fact that the
Are we having a hard
total
time
or
understanding
sum of
those
the difference
concepts?
of your x value
Sa dyan na ba,
and the
Sabton?
mean will
Unsa day
always
kalahian
be zero.
sa Euler path o Euler
Sabi ko po,
circuit sa
that is a
Hamiltonian
fact.
path
Pag
sa
wala akong
non-Hamiltonian
ganit
circuit?
fact, that is
What's the difference between them? Diba, last meeting we discussed about
Let's go to step number 3.
the Euler path and circuit, and this time we
Get the sum of
are
the
actually
equations,
discussing about the
you can
Hamiltonian
use the
path and
square of
circuit.
each
So, sa
equation.
Euler path and circuit, si Euler path and circuit, they are focused on the edges. Again, they are focused on the edges. Sa Hamiltonian path and circuit, they are more focused on vertex or vertices. Sa Euler path and circuit, kinahanglan matrabilan tanan ng mga lines. Okay, kinahanglan trabilan tanan mga lines. Bahala dili nimo matravel ang mga vertex. Basta kay kinahanglan tanan lines matrabilan nimo na dili ka magbalik-balik, mao na ang Euler. Pag Hamiltonian, kinahanglan matrabilan tanan mga vertex. Bahala dili na ay mga lines nga dili nimo matrabilan. As long as na-travel nimo tanan mga vertex. That is what we call Hamiltonian path and circuit. Pag path and circuit sad, pag path sa Euler o sa Euler path and then Hamiltonian path, pag sinabing Euler path, that is natrabilan nimo tanan lines or edges, but wala na kaning balik sa imo starting point. Muna ang Euler path. Sa Hamiltonian circuit, natrabelan nimo tanan vertex pero wala na kaning balik sa starting point. Sa Euler circuit o sa Hamiltonian circuit, ang Euler circuit is natrabelan nimo tanan edges and then you go back to your starting point. Now, where into Hamiltonian circuit, you travel all the vertex once ra. Again, once ra dapat ha. Travel nimo tanan vertex ka isa ra dili pwede magbalik-balik and then you go back to your starting point. That is what we call Hamiltonian circuit. And if that is a Hamiltonian circuit, then we can say that that is also a Hamiltonian graph. A Hamiltonian circuit is what we call a Hamiltonian graph.
Calculate for
Is
the
it clear?
Step number 2, get the sum of the
Okay,
division.
so
Step number 3,
okay, in here, is there a way to determine whether a given graph is Hamiltonian? Okay, that's a question mark. So, natin gitawag na Dirac's theorem. In Dirac's theorem, we will consider a connected graph with at least, ang pinakagamay is tulok ka mga vertices. Again, kung may at least, ang kinagamyan na is 3 vertices and more. And no multiple edges. So let n be the number of vertices in the graph. Again, Cn is what we call the number of vertices in the graph. If every vertex has degree of at least n over 2, sa pagaling tong degree,
ang inyong denominator will be n minus 1. But if
nakalimutan sila sa degree ba na nasa ato lesson 1? If every vertex has degree of at least n over 2, then the graph must be Hamiltonian. Again, usa ng degree ka ng sa kada vertex na anatay pila ka lines nga nag-connect. May ka degree pila ka lines ang ni-connect sa isa ka vertex or sa kada vertex. Again, if ang ato kada vertex daw kay nasa degree of at least n over 2, then the graph must be Hamiltonian. Okay, so example, determine whether the graph on the right side is Hamiltonian or not. If it is, find a Hamiltonian circuit. If it is not, explain why. So, we have here an example of Hamiltonian. No? Anong Hamiltonian maning first graph here? This one. Is this Hamiltonian? Or yeah, naging una din rin na Hamiltonian siya. So, you will just have to explain na lang anong Hamiltonian maning siya.
3.05.
Because
Square root ng 9.2975. You can use your calculator to get the square root.
waya ni balik sa ija sukod.
Maghibog mo o inyong manong-manong
We're talking about Hamiltonian.
square ng hisgutan. Basta dili perfect square, gamitin na lang ninyo lang calculator. So again, 3.05
Edges.
that comes from 9.29.
Uy, pag edges, ato siya sa Euler. We're talking about Hamiltonian.
That is approximation lang. Kung imong i-multiply si 3.05 times 3.05, ang answer ana will be close to 9.2975.
Nagian tanan vertex once.
3.
Okay, that's correct. Nagian ni siya tanan vertex once. And then niagis, ning balik siya sa starting point.
Which is close to
Okay?
9.29.
Again, kung may ta Hamiltonian ha, Hamiltonian na to gingon. So, we're talking about Hamiltonian circuit. Again, matawag na to siya na Hamiltonian if Hamiltonian circuit siya. So, kibali, example ana is, ato takang A mag-start, B, E, F, C, D, o A. Diba? So, we travel tanan ng mga vertex. Again, we travel tanan ng mga vertex. And then, at exactly once ra, and then we go back again to the vertex or the starting point, which is A. So, possible. Basta na natin makita na ni balik siya sa ija starting point and na-travel ni siya tanan vertex na waya ka nagbalik-balik sa ila. That is Hamiltonian. So, pila man ang degree diri nila?
Solve for the deviation or the sum of the deviation. Third, solve
If
for the
every
sum of
vertex
the
has degree of at least n over 2.
Given
Pila man ang degree sa A na vertex?
square root of the standard deviation. And then you squared lang ang standard deviation to get the
3. Yes. Sa B, 3 gihapon. Sa E, 4. Sa F, 3. Sa C is 4, right? And sa D is what gihapon?
From the group.
Sa C, 1, 2, 3, okay, 5 ba dyan. So that is what we call degree. Okay? Now let's have this second example. So ning traveler gihapon si siya sa tanan vertex. Pero the question is, can you give me an example? No, of kanang sa pag-travel nato na matawag nato si na Hamiltonian. You just have to give me at least one example.
Extend part, extending and measures of this question. You will answer this one individually. So once you're done, you submit it for So problem number 1, Mr. Anino wanted to know the ages of his 15 students in Math 100. So after asking his students, these are the ages.
You can give me an example.
His students. So na
matravel na to tanan vertex at exactly once, and then we go back again to our starting point.
Data points. So given this data set, you will solve for the range, the standard deviation, and the variance. So problem number 2 is
Anyone can answer.
conducted a 50 item summative quiz for Math 100 class with 15 students. So the following table shows the results. So we have here first column, the name of the students, second column are their qualifying scores. Basing on this data, we will solve for the range, the standard deviation, and the variance. Hindi na may consider ng next activity. Kanilang sa duha ka activity.
Uyay mo hatag example. Medyo nakitaan. Pwede mag-start na sa A. We go to A, B, C, D, E, and A. That is A Hamiltonian.
So I will give you
Pwede sa B. B, D, C, E, A, B.
So by 6:10,
Okay.
we will be
Now, how
checking
about this
the
one?
answers.
We have here one of the graph that is not a Hamiltonian.
Okay, again, I will
So,
give you 20
what
minutes
makes
to
it
answer
not
problem number 1 and problem
a
number
Hamiltonian?
I will call a random D for those who will present the answer. Is it clear? Claro? Claro, dili. Ganong wala may manihog. Nanaamang na. Mang wala.
Regalo, mang dili man siya matawag na Hamiltonian.
Asa lagay mo doon? Diyan ka sa gawas?
Because Dili pwede tungod kay no wala tay makita na Hamiltonian. No, like for example, if we go at A, B, B, E, C. So kinahanglan kay kung asang imo starting point, dito ka mag-end. Na kay natrabila naman imo tanan ng mga vertex, so you cannot go back to A na. Or if you say magsugod ka sa E. So ano ka? A, E, A, D, B, and then dili na ka mo connect sa C. Iwaya na may line. So that means this is not a Hamiltonian because it is impossible to travel in any vertex and go back to the starting point. That should be your reason. Okay, so anyways, more to siya about Hamiltonian graphs and circuits. Let's not just focus in this one because this is just all about the weighted graph, no? So we are still, dili naman natin appeal ang weighted graph and circuit. So we'll just focus on Hamiltonian graphs and circuit. Now, do you have any questions, guys?